Assalamualaikum and good morning to everyone. Now we will go on the topic for the basis. Okay, kalau basis ni dia kena ada dua syarat. Okay, the first one is V, the vector, span the V. Okay, V ni V besar lah. V besar ni maksudnya vector space. Okay, nampak ni? V besar ni maksud dia vector space. So V ni V kecil tau. V yang dalam vector space. Vector space ni macam satu besar lah, satu sistem yang besar, vector space. So V ni adalah vektor-vektor kecil tu lah. So dia dalam V. So kita kena make sure all of this V kecil ni is span V. Yang tu yang first. Kau nak buat span V, kita kena buat apa? Dia maksud dia macam sama macam linear combination. Okay, kita kena cari coefficient of every vektor kecil ni. Cari, kalau dapat, then it means that all of this V is span V. Okay, the second one, all the V1, V2 and Vk must be linearly independent. So kalau linearly independent, it means that the A1, A2, the constant, the coefficient, okay, must for its vector. Okay, once again, the coefficient for its vector, okay, must all be 0. Then it is called linearly independent. So bila dia linearly independent, dia span V, then we can call that all the vectors kecil ni is the basis for the vector space. Okay? So we have a question here. So it was asked to show that the set S where V1 is this vector, V2 we have V3, we have V4 is a basis for R4. Okay. Untuk example saya, okay, R4 ke or R4 ke is the same lah. R4 means that it is in the 4D space. Okay, kalau R3, 3D space. Kalau R2, maksudnya 2D space. Tapi kalau R4 ni, atas ke bawah ke dia duduk, dalam example saya ni lah, contoh saya, dia adalah 4D space. Okay? So, dia suruh cari basis. Kalau cari basis, dia kena span V. Satu lagi kena linearly independent. Ingat, linearly independent, bukan dependent Okay, let's start and do the solution. Okay, see here. Okay, untuk buat dia linearly independent, therefore the V1, V here, okay, V dekat sini must be 0. So kita ada coefficient A1, A2, A3 and A4. So V1 ni mana dapat ni? V1 ni dapat V2, V3 dengan V4 ni kita dapat koordinat daripada soalan. Then when we have like this equation in this form, then we transfer it in the form of linear system. Dah dapat in the linear system, then make it in the augmented matrix. So see here, A1 dia 10, 10. So remember this is A1 for the first column, A2 for the second column, A3 for the third column and A4 for the fourth column. So every A1 must be in here. Okay? So A1 kita 10, 10. So 10, 10. So A2 kita 0, 1, negative 1, 2. So 0, right? 0. And then the second one, the second row is 1. So it is 1. See, 1. So negative 1. So negative 1. And then 2. 2. Okay? And so on. Okay? So when we have in this form, make it in the augmented matrix. And then solve it until we get in the RREF or REF. Okay? Solve it. How to solve it? Using the ERO lah. Okay? Okay, as I have said in the example earlier, okay, at the recordings earlier, okay, when you want to solve the ERO for the matrix, make sure you solve it column by column. Maksudnya first column and then second column and then third column. So what it means by solve it by column? So it means that at the first column, okay, make sure this is the leading one. Other than leading one, at each column, make sure it is in the value will be 0. Okay. So on. Okay, untuk second column pun sama juga. Cari leading one. Okay, if let's say the leading one is here at the second row. So make sure leading one at each column other than the leading one, other value at each column must be 0. Okay, buat macam tu. Okay, column by column. Okay, so what you got here, okay, I got in the RREF and in the form of identity matrix. So senanglah, nilai dia senang dapat. So from here we can say that this is A1, right? The first column, the first column is A1, the second column is A2, the third column is A3, the fourth column is A4. Therefore, we can say that A1 equals to 0, A2 equals to 0, and so on. So from here, we can see that the coefficient for each vectors all 0. Kalau all 0, kan, maksudnya V1, V2, V3 and V4 linearly independent sebab semua 0, kan? So dia dah dapat satu satu syarat untuk jadi basis, iaitu linearly independent. So kalau nak buat dia span V, okay, kita tengok contoh seterusnya. So here for the contoh for the syarat 2 to get the basis. Syarat 2 S. Okay, S ni means that the set lah. Set ni maksudnya set dia lah V1, V2, V3, V4. Set vectors dalam vector space. Okay, so we must make sure that S spans R4. So dalam vector space ni bentuk dia dalam R4. Maksudnya 4D space. Okay, dalam bentuk 4D space. Dalam contoh soalan ni lah. Okay, so nak tahu dia span ke tak, so let's say V equals to A, B, C, D. Sebab kita tak tahu nilai dia apa. It can be 0, it can be 1, it can be 100, it can be negative 1, it can be 0.5. Okay, tapi kita tak tahu value dia apa. Soalan pun tak bagi tahu. So nak test the span V, therefore we make it in a variable. This variable, let's say it is the real numbers. So A, B, C, D ni adalah satu real numbers yang kita tak tahu nilai dia apa. Tapi it can be any real numbers. It can be 0, it can be 0.5, it can be negative 1 or 100. So kita just declare dia suatu variable. That variable are the real numbers. So this is the V. So nanti ganti je lah V ni dengan A, B, C, D. Kita kena buat in this form ya. So since we have V dia sampai 4, ikut soalan V dia sampai 4. Okay, tengok balik soalan tu. Okay, see this soalan untuk tunjuk dia basis. Kita have V1, V2 and V3 and V4, right? So therefore we have in this kind of form lah. So kita ada V1, V2, V3 and V4, and this is the big one, the V1, combination of these vectors. Okay, so V1, so cari daripada soalan kita tahu V1, V2, V3, V4. So memang dia bentuk dia dalam this form, and every these vectors got its coefficient. So this is the coefficient. Make sure dalam bentuk macam ni lah. Memang macam ni. Jangan tanya kenapa, memang nak solve dia memang macam ni. Okay. Okay. Therefore, ABCD ni satu vektor lah. Okay. So, kita solve dia. Kita solve dia sampai dapat in the form of RR, EF or REF. Okay, kita solve dia. Okay, mula-mula dapat form macam ni. Lepas tu kita dapatkan dalam bentuk linear system. Okay, mula form macam ni kan. Lepas tu dapat bentuk linear system. And then make it in the augmented matrix. Dapat bentuk augmented matrix. Make sure it is in the RREF or REF form. Okay. So lastly, okay, I got like this one. This is in the RREF form. So I got this value. So we have value A1, A2, A3 and 4. We got value. Okay, we got the value for A1, A2, A3 and A4. We got the value for the constants in these vectors. So therefore maksudnya dia dah jadi span. Dia every vectors, okay, untuk A1, A2, A3, A4 ni dia ada vectors dia. So every vectors spans the R4, okay. So since that every vectors, the set for every vectors, so we have V1, V2, V3, V4 spans the R4, okay. And then before this we have showed that it is linearly independent, therefore it is a basis for R4. That's it, okay.